Hello everyone. I hope that you all are doing well. And today we are starting with our next section, Best Practices Part 1 for ASP. So in a previous section, we have learned some basic optimization techniques which you all are already using. I have added some few topics in it like ASP.NET Developer Roadmap in a 2022. Now this particular roadmap is based on everyone's um, point of view, okay, everyone's way of learning. You can go ahead with it or you can just skip it. Next, standard practices, some basic optimization techniques we have learned, we mentioned in those videos. Next one is the efficiently handle exceptions, then async await best practices, caching, connection pooling, and the clean architecture with ASP.NET Core 8. So all these videos are related with the techniques which you all are already using in your products and some little bit enhancement in those techniques. Now, in this section, we will learn some different things, okay, on a basic level, how to do the things and what will be the better solution or optimized solution for the particular scenario. So in previous section, we covered like some very basic things like how to name the variables, methods, classes, or a kind of a project. So name things well. There will be one class per file. Use properties, not variables. Method should do one thing. Okay, one method should do only one task. Okay, one functionality it should accomplish. Next one is whatever you are doing, just keep it simple. Don't complex the things. Be consistent. Use the curly braces for each statements. Use some enhanced loop if you are iterating through the collections, and avoid global variables. Use public verifiers or modifiers whenever it's necessary. Never trust the user. Always verify the user and plan before you build, obviously. Some such basic things we have covered. Then there are some optimization tricks are there. Like the first tip is like finish the code. Whatever you have started, finish it. I know there are immense pressure and lots of projects and functionalities are a little bit complex, but when you start it, complete it, don't leave it. And this is only leads to more personal technical depth, that you will be under more stress and you will think that okay, I will finish it later, and for that particular time you will feel that particular uh, stress, like okay, I have to complete this thing and this is the deadline and all. So just divide the task as per your capacity and complete it. So the only leads to more personal technical depth, that you'll able under more stress to finish it later. If you don't want to let the code grow out of your control, this is the completely up to you. Okay. Now, whatever you have started, try to complete that small task today itself. Take some breaks for fresh air, some fresh water. Okay, you just take a small breaks and just complete that particular task. Now, something like enforce standard coding. Okay, if programmers on your team have a different preferences, like they are standardizing the code in a different way, just manage in between your teammates. Okay, to perform the curly brackets, what kind of a spacing and naming conventions you are following. Just standardize those things before you start, or any other aspects of your code. This makes it frustrating to share the code across the projects because you are not maintaining the same standard. So we have got the code tools to do that thing automatically. And you can use those tools also if you not want to, or if you don't feel to use those tools for standardization, then you can just define the definitions of what kind of a standards you are following throughout your teammates. That's it. Next, obviously, discipline is required, documentation is required. Then, what kind of a patterns, what kind of algorithms or a flow charts your team uh, accepted and followed while development. Okay, you absolutely must to have a wiki topic or markdown file in your project that link how to apply every major pattern on your project. If you do this, it will reduces the wasted time. So it will not waste the time of your development. Then must review the code, what code pattern you are doing, whether we can write this particular block of code properly or not. We can optimize this particular section in a latest way, in a latest according to latest techniques we have or not. Just check the performances of your code, okay, whether you can improve the performance, what exactly, where it's lacking, whether it's taking so much of time and unnecessary, whether we have just lengthened the code. Sometimes what happens, the task is small, we can reduce the line of code, but we just enlarge that code in such a way that okay, we can mm, compress that code, okay. So for that, code reviews are required, okay. So if you are not able to identify the problems or optimization things in your code, you just ask the other people in your team, okay, this is the code, whether it's optimized or not. If it is not, they have suggested something, just optimize that code. This kind of a periodically code review should be happened. Next, lots of things are there which we have discussed in our previous sections, like how efficiently we handle the exceptions. Okay, we can create our customized exceptions, in which cases we have to use async and await, when we can in skip those things. What kind of a different uses of caching? Caching thing we will cover in this section also little bit. Next one is the connection pooling. Okay, one is the clean architecture with ASP.NET Core 8. Now, if your project is going on, it's already started, obviously you can't apply this clean architecture. But I suggest whenever you are trying to develop a new project in ASP.NET from the scratch, just go ahead with this clean architecture, which is really beneficial. It's divide your what different kind of file folder structures in a better way for the better understanding, and it won't complicate the single file. So when I am reviewing the code, I saw there are lots of files which are overburdened. There are near about 20 to 30 functions are there. Okay, and each and every function having the huge amount of line of code. So as we discussed in a previous section also, in a standardization practice and best optimization techniques, code should be simple. One method should do one task. So these things we are violating somewhere. So again, by using clean architecture, you can perform those things. So you can create the domain-centric functionality, domain-centric architecture. So whenever you are starting to develop a new ASP.NET project, you just go ahead with the clean architecture. Now let's start with this particular section and first topic of this section, and that is nothing but the hot code paths in ASP.NET. Now, what exactly it is? The hot code paths are the code paths that are frequently called and where most of the execution time occurs. Now, these are the block of codes which are frequently accessed, and it's taking your more than 50% time for the execution. So hot code paths limits app scale out and performance in a ASP.NET, because these things are frequently called, and that is the location where we need to optimize the code, where we need to check the performance of that code. Now, this misconception that the fast code must be the ugly, and unfortunately, it's still alive. So we says that okay, fine, I have written the code, it is working fine, and I don't think that it should look cool, it should look optimized, it should perform. We have to check it on the performance criteria. So this particular thing is, this misconception is already there and it's still live. So when we are developing the projects, at that time also we are like, okay, I have written the code and this code is working and this is stable, but we are not, we were not checking the code performances, whether we can optimize the things, whether it's looking properly or not, it's following all the rules and regulations for the standardized code or not. So also there is an anti-pattern of the leaving the performance related work till the end. So what we normally do, this code is working, performance thing, we will check it later. Okay. And uh, then nothing can be changed. But what happens, no? At the end, we can't change that much things. Okay, we are like, okay, everything is done, and now for the performance requirement, we can't change the code. So fortunately, there's a lots of people writing the code that is fast and easy, and which is still people are following the things. So under that, understanding and optimizing the hot code paths is crucial for improving performance and scalability of ASP.NET applications. Let's dive into this topic with the explanations and examples in more detail. So these are the hot code paths is a path that is critical, either because it's something that is really intensive, or because of its latency. It's latency sensitive. For example, former an example of the former is a long for loop, or a large nested iterations that does some core computations, and it takes so much of time. So in this example, an example of the letter is measure, layout, draw the logic for your UI, which must be as fast as possible to avoid the dropping the frames. In general, there are some code paths which you want that take least amount of time, whatever possible. And the reason is obviously the various specific reasons. Okay, UI should be fast, and these logic, business logic should be fast. But what you have done, you have written that particular logic in a long loop or nested iterations are there. So these things we need to avoid. Sometimes we have to find out whether there is any better way or optimized way to do it. So the execution paths in your application or a compiler in which most of the execution time is spent, and thus which are potentially executed very often. So now hot code path in ASP.NET are the sections of a code that are executed frequently and consume significant portion of our time. ASP.NET applications, these are typically found in a request process pipelines. Then there are some database queries, complex business logics, where lots of ifs, for loops, and all these things are executed. Frequently accessed API endpoints, resource intensive computations. Okay. So these kind of a section of codes are considered as a hot code path. And obviously without API, without database, without business logic, we can't write a product, right? We can't create an application. So these things we have to take care. So hot code paths become a bottlenecks, limiting an application's ability to scale and perform efficiently. So understand whether it's hot or not. Okay. Now we discuss what exactly the hot code paths are, what are the sections. We find out these kind of a block of codes, but we have to find out whether it's a really that much critical kind of a code or not. When taken optimizations and designing for performance is taking into consideration the hot parts of the execution. If a specific case covers 80 to 90 or a 99% of the execution, optimization introduced in there will be a likely payoff. It is important. So consider you have written this particular code, and that code is continuously executing, and it's taking 80 to 90% of your execution. So obviously we have to check the performance of that code. It's not like that not so hot paths should be neglected. So it's obviously we are just considering these things, but there are some block of codes which are not frequently used, but they are important, right? So that thing also we have to take care. I'm noticing that recognizing the hot paths and adding the single if might change a lot. So it's not like hot code paths. We have to write a different code, and different logics and business logics are there, are different tools and techniques. So we have to use, no, simply you just have to add a if condition in it. To make this happen, we need to improve some enablers. We need to think about this hot cases upfront. And let's take a look at the examples in ASP.NET. So there are some value stacks, read-only sequences, efficient database queries using the projection, caching for the complex computations, batch processing and aggregation. So these things, by using these things, we can go ahead with we can cover and uh, we can just optimize this hot code. Now identify hot paths with the flame graph. Okay, so this particular is suggestion by the ASP.NET documentation. So they are like, okay, if you want to check the performance, you can go ahead with the flame graph uh, technique. The flame graph in the CPU uses an instruments tool help you identify hot paths in your code by visualizing a call tree. So they identify the call tree, okay, and based on that, you will get to know, okay, which particular method is taking what amount of time, what kind of a spaces of or a memory it's required. So flame graphs are the visualization of a categorized data created to visualize stack traces of a profile software so that the most frequent code paths can be identified quickly and accurately. The graph gives a visual overview of where time is being spent in your application, and you can click on specific nodes to dig into them further for the correction or for the more specifications. So these things I will show in ASP.NET documentation also. Um, Before that, I just want to mention one block of code we have. I don't know, I don't remember the Microsoft microprocess. Okay, where it is. So this is one block of code I have took from one of your product. So it's simple, it's a simple thing. Okay, we are just caching the thing. Okay, we have written the if block, then we are just writing and converting it into the JSON. If it is not cached, then we are accessing it and we are returning it. Okay, and the whole code is written into try and cache. Now we have declared three variables in it: cache entries, collections, and atom list, and all those things. Okay. Now one thing I want to recognize here. Okay. So this is the normal code we normally write in a hurry, and this is the optimized code for the same blocks of code. So first we declare this cache entries field. If this cache entries field is null, then we are returning the null kind of a test. Then again, after that, we are creating this cache entries collections, and then we are checking two conditions, whether it's a null or the count is 0. So accordingly, we are whatever the possible conditions are there where we don't need to create or where we don't need to access the thing or create the variables, it's not required, right? Unnecessary, we are creating the variable before we do the functionality. So first of all, by adding the simple if, we can check the things, okay, if it is available, whether it's a null or not, whether it's the count is 0 or not. In those cases, you can go ahead with the empty list, and otherwise then you can go ahead with the cache thing. Okay, again the cache thing for each loop, instead of a for each loop, obviously cache, it's be created by means of keys and values. You can iterate through the keys by using the cache entry collection dot keys dot these things, right? So go ahead, use the better techniques, solutions. Okay, instead of a for each, you can iterate through the keys. Just think of the things. Okay, you can write the better code by using the better techniques. Okay, latest techniques, we have those options. Okay, and I know you can write it, but as we mentioned at the start of this particular video, like the fast code is not the well written or optimized code. Okay, both the codes are working code, right? Okay, there will be the output of this code and that code, but better look and better optimized and better performance code will be the best one, right? Now, what are the examples of inefficient database queries? This endpoints retrieve all users with their post and comments as per the number of user goes. This particular query will become expensive and slow. What we are doing, we are fetching everything about that particular to the post. We are just fetching the post and comments of that particular user. Now, how efficiently we can use the database queries? So it says that this optimization version uses the projection to fetch the only required data, reduce the amount of data transferred from the database. So instead of using all the data, what they are suggesting, you can use the projection. Okay. A projection is when the entity class is projected into another class or anonymous class. This is typically done when your entity may have a very large number of properties. It's near about 12 to 13 properties in your entities, and you want to select only specific properties, but you need only few properties. For example, select product, new product dot price. We just want the price of that product, correct? So in this case, we are fetching everything, and then we are just fetching the post and comments and all this thing. So here, by using the projection, we are just mentioning that I want this thing, I want that thing, and just create that uh, selected data into one entity and then create the list of it. Okay, so it's a better way. So projection refers to the operation of a transforming object into a new form that often consists of those properties subsequently used. By using projection, you can construct a new type, and that is the built from each object. So you can project a property and perform a mathematical function on it, and you can also project the original object without changing it. So let's go ahead. Second example, complex computation in a request process. So this endpoint performs the multiple database queries and complex calculations for each request, which become a bottleneck traffic as the traffic get increased. Now what we can do, what is the solution? This is the problem. Then how we will resolve it? So caching the complex. This version uses the caching to store the dashboard data for 10 minutes and reducing the need of a frequent recalculation. So solution of this thing is just cache the thing for a particular amount of time, fetch its data, and after that amount of time, fetch a new data, refresh data. Okay. Next, repeated computations. Like in a previous code also, we have said that there is a repeated calculation. In this examples, the get user details methods makes multiple calls to the user service, potentially resulting into repeated database queries or complex calculations and computations and fetchings. Okay. So what we can do? We can use a batch process here. Just add the things into the batch and one at a time, just execute the batch operation and then execute. Next problem is value stack. Okay, this is the one of the basic concept. Okay, I hope that you know about it. So optimizing hot code paths in ASP.NET by using value stack. The value stack is nothing but a struct introduced in the ASP.NET code to optimize the certain asynchronous scenarios. Okay. So normally what we do, we write everywhere async await, async await, async await, right? Now there are certain situations where we don't want to async and await. If it is working, we have the requirement it should work in a synchronized way. Then at that time, so it's a design to address a specific performance issue in a hot code path where the method is often completed synchronously, but needs to be declared as asynchronous for occasional asynchronous operations. So why value stack matters for the hot code path? It reduces the allocations, then optimize for synchronous completion and backward compatibilities. How value stack optimizes hot code paths? It synchronous path optimization. It reduces the pressure on a garbage collection and pooling with the I value stack. If you want to understand the value stack functionality and details, you can go ahead with the PPT. Some extra code texts are written over there. So as a struct, value stack doesn't allocate memory on a heap. Okay. So unlike the task, in normal cases we are using, so unlike the task, which is a class. So this reduces the allocation, can significantly improve the performance in a hot code path. So value stack is designed to be more efficient when the operation completes synchronously. So which is often the case in a scenario like caching or prefetching the data. So when there is nothing in a cache or prefetched, the data is not available. So obviously the task should be completed. Existing code can await value stack just like task, making it easy to adopt without breaking the changes. So some things are available related to the value stack. You can go ahead. Now, in this example, there are the code before and after. Okay. So the before version always allocates the task even when returning the cache data. But in case of after version, wait a minute, let me show you. Laser pointer. This is the before version and this is the after version. Okay. So before version, we are able to see that the return type of the method is a task, right? So it's always returns or allocate the task even when the returning cache data. The after version uses the value stack task. Okay. So value task avoiding allocation for common case of cache hits. So you just go ahead with this. The PPT is already available, okay? So if you want to revisit it, it is available. You can download it. Now, how to consume the value stack? Just a minute. Okay. So in this slide, value task is like simple awaiting. Normally, we just getting the data a synchronous way by means of a key, and we awaited for the whole fetching, and then we are assigning to the result. So this works just like normal task, making adoption easy. Now, optimized handling is by just adding if and else. If you look at it, no, it's simple if and else. So data service, we are just fetching the data by means of a key in a value task. Value task, if it is completed, it normally handles the data in a synchronous way. Otherwise, if not, then it is just performing the asynchronous way. Okay, so this allows for even faster processing when the operation completes synchronously. So if already it's completed synchronously, there is no need to await and there is no need to go ahead. So this simple if else and adding the value task, that is little bit easy and little bit faster and optimized way. So when to use value task? So methods that are frequently called and often complete synchronously. Okay, so the method which performs synchronously very well, there is no need to add a synchronous. And synchronously, it is faster. Very few business logic, very few fetching and all API accessing on all. So in that case, you can go ahead with the value. Performance critical code paths where reducing the allocation is important. Performance based criteria or code you have and where uh, uh, allocation, so much allocation is not required and it's totally we are focusing on the performance of that function, then at that time you can go ahead with the value. That API that need to be asynchronous for compatibility but are often used synchronously. There are certain APIs, okay, certain tasks are there. We have written those tasks as asynchronous, but often we are that those tasks are performed synchronously. So conclusion is value task is a powerful tool for optimization hot code paths in ASP.NET applications, especially for those which having the mix of synchronous and asynchronous operations. By reducing allocation and providing flexibility in how it's consumed, the value task allows developers to fine-tune the performance critical parts of their applications without sacrificing the benefits of asynchronous performance programming. So whenever you observe that this particular method or task is a mixture of a synchronous and asynchronous operations, then you can go ahead with the value task. Okay, rather than only using the task and make it asynchronous totally, because some part of that thing is work functioning or working, executing synchronous. Okay, so there is no use or there is no point to wait. Okay, asynchronously. Now read only sequence. This is again a one way to optimize the hot code paths in ASP.NET. This thing we will cover in a next video. I think it will be little bit lengthy, so we will cut it here and we will go ahead with the next video for it. So thank you, take care, keep going, bye bye.